So, when I say the word salt, what's the first thing that pops into your head? I bet you're thinking of the white stuff you sprinkle on your food. And you're not wrong. But in chemistry, the word salt means, well, a whole lot more.
You see, in the world of chemistry, salts are literally all around us, often in places you wouldn't expect. Take farming, for example. These soya seeds? They're coated in copper sulfate. Yep, that's a salt, to protect them from fungus. And these big bags are full of ammonium nitrate, which is another salt that farmers use as fertilizer. So you see, salts are a pretty big deal.
So in this explainer, we're going to break it all down. First up, what a salt really is. Then we'll look at how different acids create different salts. We'll even walk through 2 key ways to make them in a lab. And of course, we'll wrap up with a quick summary of everything you need for your exam. So let's get into it.
Okay, section 1. Let's get to the bottom of this. What actually is a salt?
From a chemist's perspective, it's actually really straightforward. A salt is simply a compound that's made when an acid reacts with another substance. That's the key. An acid plus something else gives you a salt. This is the main definition you've got to remember.
And you know, salts aren't just for labs, they're in your food too. If you ever look at a jam jar, you might spot sodium citrate on the ingredients list. Guess what? That's a salt. It's made when citric acid, you know the acid in lemons, reacts. See? You're probably eating different kinds of salts all the time.
All right, so if acids are the key to making salts, does that have anything to do with their names? Absolutely. Which brings us to part 2, acids and their salts.
The rule here is super simple. The name of the acid you use tells you the name of the salt you're going to get. And this table shows you the pattern perfectly. If you start with hydrochloric acid, you get salts called chlorides. If you use sulfuric acid, you get sulfates. And if you start with nitric acid, you make nitrates. You see that pattern, right? The acid's name is your biggest clue to the salt's family name. This is so important to remember for your exam.
So we know what they are, but how do we actually make them? Let's dive into our first method, which is reacting an acid with a metal.
Here's the general equation you need to know for this one. When you mix an acid with a metal, you always get 2 things, a salt and hydrogen gas.
And here's what that looks like in real life. We've got some zinc metal in hydrochloric acid. And look at all that fizzing. Those bubbles are hydrogen gas being produced. That fizzing is your #1 sign that the reaction is working and a salt, in this case zinc chloride, is being formed in the liquid. So how would you make zinc sulfate yourself? Well, it's basically 4 steps. First, you pour your sulfuric acid into a beaker. Second, you start adding your zinc metal and you keep going until all the fizzing stops. That's how you know all the acid is used up. Third, you gently heat the solution to boil off some of the water. And for the final step, you just leave it all to cool down. As it cools, you'll see these amazing zinc sulfate crystals start to form. That cool final step is called crystallization. But hang on, what if you have a metal like copper that's just not reactive enough to react with an acid by itself? No problem. For that, we've got method number 2, using a metal oxide instead. Now, the equation here is a bit different, and you really need to notice this. A metal oxide plus an acid gives you a salt and water. See that? We get water this time, not hydrogen gas. That's a super important difference to remember.
Because copper is one of those unreactive metals, we can't just drop it into acid, so we use its oxide, this black powder called copper oxide. To get the reaction started, we add this powder to some acid that we're heating up. Let's walk through how to make some copper sulfate. First, you gently heat up some sulfuric acid. Second, you start adding the black copper oxide powder. You'll know it's working when the whole solution turns this beautiful blue color. Third, you've got to filter the mixture to get rid of any leftover black powder. What comes through is your pure salt solution. Fourth, you gently heat that blue liquid to let some water evaporate. And finally, you just let it cool down and watch those awesome blue copper sulfate crystals appear.
All right, deep breath. Let's pull everything together into a quick summary for your exam. These are the absolute must-know points.
Okay, so remember, a salt is what you get when an acid reacts. The acid's name tells you the salt's name, right? Sulfuric acid makes sulfates. For reactive metals, it's method 1. Acid plus metal gives you a salt and hydrogen. For those unreactive metals, you need method 2. Acid plus a metal oxide gives you a salt and water. And don't forget those key lab skills, filtering to clean up your mixture and crystallization to get your pure salt crystals.
So, to wrap up, let's put it to the test. We know copper is an unreactive metal. So which one of our 2 methods would you have to use to make copper sulfate? And more importantly, why that one?